Hello. The last type of problem I'd like to do in section 3.2 has to do with compound probabilities. This is a very typical question that you would see on your exam. I'm going to go through each part of problem number 28. The probability that a person in the United States has A positive blood type is 31%. 3 unrelated people in the United States are selected at random. Find the probability that all 3 have type A positive blood. Well, the probability that one person has type A positive blood is 31 out of 100. The probability that 2 people are selected with type A blood is 31 out of 100 times 31 out of 100. And the probability that all 3 have type A positive blood is 31 out of 100 times 31 out of 100 times 31 out of 100. Of course, in a problem like this, you're best off using a calculator. And when you're done, you're going to get a result that's 0.030, which means about 3% chance of this happening. What's the probability that none of these people have type A positive blood? Well, if there's a probability that 31% have type A positive blood, then there's a 69% chance that they do not have A positive blood. Well, 69% is 69 over 100. So this would be 69 over 100 times 69 over 100 times 69 over 100. Again, this would be solved through the use of a calculator. As you're going to notice in this case, it's 0.329. You would expect this, of course, to be much higher than the other because you have 69% chance here as opposed to 31% chance. These are not complements of one another, just the fact that all 3 have type A positive and the type that none of them are not complements of one another. We're going to see where the complements come into play here. Find the probability that at least one of the 3 people has type A positive blood. Well, what you will realize here that at least one is the complement of none. Because none of them having it means that this will work with one person having it, 2 people having it, or 3 people having it. This would be none of them having it. So the best way to calculate this is simply 1 minus 0.329. That'll give me an answer of 0.671. Which of the events can be considered unusual and explain? Well, any event that has less than a 5% chance of occurring is considered an unusual event. This has a 32.9% chance of occurring. This has a 67.1% chance of occurring. This one has a 3% chance of occurring. So the only event that would be considered unusual would be that all 3 have type A positive blood, because this result works out to be less than 5%.